So Pythagoras is one of those things that's been around for quite literally millennia. It was used to help build the pyramids, we know that for a fact, but it wasn't actually proven in the ancient Egyptian times. It was eventually proven by a scholar named Pythagoras and his students, and that's what we're going to learn today. Now, I'm pretty sure that you have been taught Pythagoras with a squared is equal to b squared plus c squared. I don't teach it like that. Hope you enjoy my way. I find it a little bit easier. So my way is big square, little square, plus or minus root. And that's the mantra. And I'm going to say it a lot. Big square, little square, plus or minus root. So let's look at the first one. Let's say that I want to find that length, and this is 3 meters, and this is 4 meters. Okay, back to the mantra. Big square, little square, plus or minus root. Which is the bigger number? 4 or 3? So the bigger number is 4. So it's big square. Then the little one, little square. Now I want to know, is it a plus or a minus question? And this is the cool part. If you highlight that you've got this length, and you highlight that you've got this length, there is a plus. So this is a plus question. So back to the mantra, big square, done it, little square, done it, plus or minus, it's a plus, and then root. So let's work that out. So I've got the square root of 16, add 9. So that is the square root of 25, and so the answer is 5. So x is 5. Big square, little square, plus or minus root. All right, let's try another one. Let's say I gave you this to be 13 centimeters, and I gave you this one to be 5 centimeters. Okay, let's stick with the mantra. Big square, little square. So what is the bigger number? The bigger number is 13. So I say big square. What is the little number? The little number is 5. 5 squared. Now, is this a plus or a minus question? Well, I've got the 13 and I've got the 5. That doesn't make a perfect plus. So if it's not a perfect plus, it's a minus. So I've got big square, little square, root. Ooh, wrong pen. Okay, plus or minus root. So the square root, or 13 squared is 169, minus 5 squared is 25. So that gives me the square root of 144, which is 12. And so I now know that this last length is 12. Okay, so the mantra, big square, little square, plus or minus root. Right, so we're now going to practice 5, and I'm going to ruin the secret, or the surprise, sorry. They're all plus questions, but that's not the point. The point is that we're practicing, okay? So in every case, the mantra is big square, little square, plus or minus root. So the big square is 4, the little square is 3, this is a plus question, and we root. For those of you who are paying attention, we've already done this question, but that's not the point. We're practicing. So we get the square root of 25, which is 5. Okay, we've also actually already done question 2. Now, why do you think that? Well, they're called Pythagorean triples because what happens is it works out perfectly with no decimals. And those are called Pythagorean triples, and there are a few in here. So let's try question 2. Big square is 12. Little square is 5. I've got 5. I've got 12. So that is a plus question. So that gives me the square root of 169, which is 13. Why don't you try the next 3 on your own? Pause the video, try them out, unpause, and we'll mark them together. All right, let's say that you've now tried these. So we're going to do them together. Big square, little square, plus or minus root. So the big square is 15. The little square is 8. We have 8. We have 15. It's a plus question. Square root it. So 15 squared is 225. 8 squared is 64. You add them together, you get 289. Square root, you get 17. Okay, again, big square, so that's 24. Little square, so that is 7. We have the 7, we have the 24, so that is a plus. Square root it. So I've got 576 add 49, which gives me the square root of 625, which is 25. Last one, big square, little square. Again, it is a plus question. So that is this 1,600 plus 81. And that gives me 41. So in all the cases, these are Pythagorean triples, which means that there are no decimals. That's not always going to be the case. These are nice for non-calculator papers. Stop the video, mark your work. Make sure you're doing well. Now we're going to try a few new questions, and I've made sure that these ones go to decimals. Same thing, big square, little square, plus or minus root. So if we look at the first one, what is the big number? The big number is 15, so it's big square. What is the little number? 8 squared. Is it a plus or a minus question? So I have the 15 and I have the 8. Doesn't look like a plus, so it's a minus question. And then I square root. So if I put in now all the steps, 15 squared is 225 minus 64. So that gives me the square root of 161, which is 12.7. Okay, let's do another one together. What is the big number in the second question? So out of 6 and 10, the big square is 10. So it's big square. What's the little square? 6. Is it a plus or a minus question? So I've got the 10 and I've got the 6. That doesn't look like a plus, so it's a minus question, square root. So big square, 10 squared is 100, minus 36 gives me 64, and the square root of 64 is 8. So at this point, I want you to pause and try questions 8, 9, and 10. We're going to go to one decimal place, please. All right, so hopefully you picked up all of these are minus questions. I promise the next exercise will be a mixed one. So if we look at question 8, the big square is 14. The little square is 9. I have 14 and 9, which is a minus 1. So I'm going to square root that. 14 squared is 196 minus 81, which gives me the square root of 115. And I did say to one decimal place, I get 10.7. Let's look at question 9. The big square is 33. The little square is 11. I have those two. It doesn't look like a plus, so it's a minus question. So that gives me 1089 minus 121. So that is the square root of 968, which is 31.1. Let's look at the last one. So the big square is 51. The little square is 28. Because I've got these two, it's a minus question. So that is 2,601 take away 784, which gives me the square root of 1817, and that is 42.6. Right, mark your work, see how you did with those. Now, as promised, the next exercise will be a mixed exercise. All right, for this second last exercise, we've got 5 questions on the board. You are trying to calculate the missing lengths that are all denoted by variables, A, B, C, D, E. I've made sure that we've got a mixture of questions here. Some are plus, some are minus. You've got to try and figure out which is which. I would suggest that you pause the video here and actually try these independently, and then when you're ready, press play and we'll go through them together. All right, let's do this. Now, we're going to round everything to one decimal place. If your rounding is slightly different to mine, that is not the issue. We're just practicing the Pythagoras. So if your rounding is maybe 1 off, we're not going to worry about that too much. So let's look at question 11. The big number is 7, so 7 squared, and then there's 5 squared. Because I have the 7 and I have the 5, it is a plus question. The answer to this one is 8.6. All right, so if you've got it as 8.7 or if you've got it as 8.5, as long as it's 8 point something, we're going to leave that for now. But yes, you probably should look at your rounding at some point in time. But yes, 8.6, that is the answer. Mark your work. Let's look at question 12. So big square, the big square is 12 squared. The little square is 8 squared. I have the 8 and I have the 12. That's not a perfect plus, so it's a minus question. The answer to this one is 8.9. Let's look at 13. The big one is, sorry, the board keeps moving. The big one is 32. The little one is 18. I have the 32 and I have the 18. That looks like a minus question, so I square root it, and I get 26.5. All right, let's look at 14. So the big square is 8.1. The little square is 7. I've got these two, so that is a plus. Square root it, and I get 10.7. And our last question, the big one is 31. The little one is 26. So it's big square, little square. We've got these two. Looks like a minus question here. Square root it, and I get 16.9. Now, those are all your solutions. Hopefully you got those right. What some of you may have noticed is it's always a plus question when everything is around the little square in the corner. And that should make sense. So there was your Pythagoras. Now we've got one question left to go where we're actually going to do something a little bit harder, where I'm putting two triangles together. Now let's look at this beautiful thing. The diagram below shows two right-angled triangles that share a side. The left-hand triangle has legs of 6 centimeters and 8 centimeters. Find the length of the shared side. So what they're asking me to do is find this, the value of y. So I know it's almost impossible, maybe, but you kind of have to completely ignore the other side. You need to pretend that this whole thing, for now, just doesn't exist. And you're only going to focus on the 8 and the 6 and that right-angled triangle. So if I focus on that and I think of nothing else, what is the big square? The big square is 8 and the little square is 6. I have the 8 and I have the 6. That looks like a minus question, so I subtract. So 8 squared is 64 minus 36 gives me, I haven't done this one already, 28. So I've got the square root of 28. And the square root of 28 is 5.3. So what I now know is that the length of y is 5.3. So I'm going to get rid of all this stuff because I actually need that triangle back now. And I now know that y is 5.3. Now that I've got that, I'm going to do question B. Use your answer from question A, cool, to find the value of x. And so this time we're doing the opposite. We're going to totally ignore this triangle and only focus on the other side. Okay? Now if I focus on the other side, sorry, I don't know how that got there. That's not supposed to be there. If I now focus on the other side, I have got 5.3 and I have got 10. Okay, I need to try and find that value of x. So what is the big square? The big square is 10. The little square is 5.3. Right? If there's a right angle on this side, it means that there's a right angle on that side too. So I have got the 5.3 and I've got the 10. So this is actually now a plus question. So it started off being a minus question. We got that answer. Now it's a plus question. And so we say plus root. Okay, so if I now type that into my calculator, I've got 100 plus, 5.3 squared, sorry about that, 28.09. Let's add those together and square root it, and I get the final answer to be 11.3. And so that is quite a cool question, where we've got two triangles in one, and you're going from one triangle to the other. All right, we're just doing this as a bit of enrichment. I'm more worried about just the normal Pythagoras. I might do this more in another video. Right, I hope you learned something and good luck.